Hi, this is John Whitaker for the Mathematical Analysis 2 class, and this is lecture 12, and we're still talking about Riemann-Stieltjes integral functions. We're about to get some properties about combinations of Riemann-Stieltjes integral functions. And the first fact I'd like to write up today, prove, has to do with the composition of such functions. So here's the theorem. It says, suppose F is a Riemann-Stieltjes integral function with respect to A on A to B. And we have that little m is less than or equal to f of x, which is less than or equal to big M. We have that phi is continuous on little m up to big M, and we're going to find h of x to be equal to phi composed with f of x, okay, and this is on A to B. And then what's said is that h of x is a Riemann-Stieltjes integral function on A to B. And the proof is going to be somewhat similar to the last theorem that we had, and then we're going to be looking at upper sums and lower sums and subtracting them. And we want to show that that's less than a given epsilon. And we're going to break that sum into, the difference between the sums as a sum, into different parts. Okay, so here's the proof. We let epsilon be greater than 0 be given, and we want a partition. We want to show there exists a partition of A to B such that the upper Riemann-Stieltjes sum with its partition H alpha minus the lower sum is less than epsilon. Okay, so since phi is continuous, on this closed interval from little m up to big M, this closed interval, then phi is uniformly continuous. On this interval. So, there exists a delta greater than 0 such that delta will be less than epsilon over 4k is what I've written, just like what we had before, where k is equal to the sup over little m to big M of absolute values of the phi of these, and what we'll have is that phi of s minus phi of t will be less than epsilon over alpha of b minus alpha of a if the absolute value of s minus t is less than this delta, okay? And where s and t are elements of that closed interval from little m to big M. Okay? Now, since f is Riemann-Stieltjes interval, okay, there exists, we'll say a partition P of A to B, and we'll give it a name. Say script P is equal to x naught all the way up to xn, such that the upper sum with P, F, and alpha minus the lower sum with P, F, and alpha, okay, will be less than, well, any positive number that I want, and the positive number I'm going to pick is delta squared. Okay, now just to remind ourselves, we're going to let m sub I, capital M sub I, equal to the sup of the f sub x's as x runs from x sub I minus 1 up to x sub I. That's what we traditionally do. And the little m sub I be equal to the infimum of the f of x as x is run from this subinterval from x sub I minus 1 up to x sub I. That's what we normally do. But then, and we're going to introduce some notation for the h. So we're going to call m sub I star equal to the sup over this interval from x sub I minus 1 up to x sub I of the h of x and little m sub I star equal to the infimum over this subinterval from x sub I minus 1 up to x sub I of h of x. Okay. And so what we're going to do is we categorize for each I n, I'll write right here, I equaling 1 up to n, into two cases. Okay, the first case is that m sub I minus little m sub I is less than delta, and then what we have is that m sub I star minus little m sub I star, that will be less than or equal to epsilon over 2 times alpha of B minus alpha of A. And that's because of the continuity. In case 2, that's where the m sub I minus little m sub I is greater than or equal to delta. And then, in this particular case, we look at the m sub I star minus the little m sub I star. That's going to be less than or equal to 2 times k. Okay. Well, we've already defined what that k is. So since U, the upper sum, minus this lower sum with this partition, alpha, is less than delta squared for this partition, we have that delta times the sum over the i's such that we're in the first case, m sub I minus little m sub I is less, I'm sorry, the second case is greater than or equal to delta, and this is the delta alpha sub I that this quantity is going to be less than or equal to the sum over the i's such that the m sub I minus little m sub I, so this is the big M sub I, of m sub I minus little m sub I times delta of alpha sub I, which is going to be less than delta squared. So, this sum over the I such that the m sub I minus the little m sub I is greater than or equal to delta of the delta alpha sub i's. We're going to divide both sides by delta, is less than delta itself. Okay. So now, if we look at the upper sum with the same partition with h in alpha minus the lower sum with the same partition with h in alpha, this is equal to the sum over the I such that the m sub I minus the little m sub I is less than delta, and that's with m sub I star minus little m sub I star times the delta alpha sub i's, plus the sum over the I such that we have the big M sub I minus the little m sub I to be greater than or equal to delta of the m I stars minus the little m I stars times the delta alpha sub i's. And then this is going to be less than or equal to epsilon over 2 times alpha of b minus alpha of a times this sum of the i's such that m sub I minus little m sub I is less than delta of the delta alpha sub i's, plus here we're going to pull out 2k. This guy's going to be less than 2 times k. So the sum over the i's such that the m sub I minus m sub I, little m sub I is greater than the delta times the delta alpha sub i's. Now, this is just less than. It's less than epsilon over 2 times alpha of b minus alpha of a. Okay, and then this sum, well, it's part of the alpha sub i's, and their distance from each other is going to be less than the difference from alpha b minus alpha of a. Plus 2k, and here, this sum, as we've shown earlier, just earlier in this proof, on the other board, is going to be replacing this sum. It's going to be less than this delta. this is going to be equal to epsilon over 2 plus, here, this is 2k, and the deltas we picked such that they were less than epsilon over 4k. And so that's equal to epsilon over 2 plus epsilon over 2, which is less than epsilon. And so that is the proof. Excuse me. Next theorem that I want to do, the last theorem of this lecture, somewhat a long proof, really 2 parts in one. It says if f sub 1 is Riemann-Stieltjes interval, and f sub 2 is Riemann-Stieltjes interval on A to B, then f sub 1 plus f sub 2 is Riemann-Stieltjes interval, and C times f sub 1 is Riemann-Stieltjes interval, where C is a constant. Moreover, the integral of f sub 1 plus f sub 2 d alpha will be equal to the integral of f sub 1 d alpha plus the integral of f sub 2 d alpha. And the integral of c f d alpha will be equal to c times the integral of f d alpha. So, as proof, we'll let f sub 1 be an element of the Riemann-Stieltjes interval functions, and f sub 2 also the Riemann-Stieltjes interval. Okay, on AB. And we'll let C be a real number. Okay, what we're going to do is to define F to be equal to f sub 1 plus f sub 2. Okay, we're going to let epsilon be greater than 0 be given. So I'm thinking of that main theorem that we have that shows that something is Riemann interval. That means that the upper sum minus the lower sum will be less than epsilon, given any epsilon. If their existence partition makes that true. Now, for any partition, script P of A to B, say P equal to x sub 0, x sub 1, all the way up to x sub n. Okay? Then the nth of f sub 1 over some of these subintervals, x sub I minus 1 up to x sub I, plus the minimum of f sub 2 over these subintervals will be less than the minimum of their sum, which is just f sub 1, or just f of x over these subintervals. Let me say one thing about this. So the smallest guy for f sub 1 plus the smallest guy for f sub 2 is going to be less than or equal to the smallest guy of the addition of f sub 1 and f sub 2. The only time that they're going to be equal, really, is when the smallest guy for f sub 1 and the smallest guy for f sub 2 happen at the same spot, same x value. Okay, and similarly, we have that the soup of f over these subintervals is going to be less than or equal to, so that's the soup of the sum, the soup of f sub 1 plus the soup of f sub 2 over the subinterval. Okay. So this gives us an inequality with these sums. So we have that the lower sum with f sub 1 alpha plus the lower sum with this partition, this is any partition, of f sub 2 with alpha is going to be less than or equal to the lower sum of the partition with f, that's the sum of f sub 1 and f sub 2, which we know to be less than the upper sum with f, which is less than the, or equal to the addition of the upper sums of f sub 1 and the upper sum with f sub 2. So we have this long string of inequalities here. Now, since f sub 1 is Riemann still disintegrable, there exists a p sub 1 that's a partition of A and B, such that the upper sum with p sub 1 of f sub 1 and alpha minus the lower sum of p sub 1, f sub 1 and alpha will be less than epsilon over 2. Epsilon is something given to us. Okay. Similarly, since f sub 2 is a Riemann still disintegrable function, there exists this other partition possibly, such that, I call it p sub 2. The upper sum of p sub 2, f sub 2 and alpha, minus the lower sum of p sub 2, f sub 2 and alpha, will be less than epsilon over 2. Okay. So to kind of combine those two partitions that we have, we let P star be the common refinement. That's P sub 1 union P sub 2. Okay? And as I said, P the common refinement. Of partition 1 and with partition 2. Okay. Then what we have that the upper sum with this refinement partition of f sub 1 and alpha is going to be or minus the lower sum with this partition of f sub 1, this refinement partition and alpha. Well, that's going to be less than epsilon over 2. And similarly, the upper sum of this partition, f sub 2 and alpha minus the lower sum of this refinement partition of f sub 2 and alpha, it will also be less than epsilon over 2. And that follows from the inequalities that we had involving the upper and lower sums for f sub 1 and f sub 2 with p sub 1 and p sub 2. And the refinements had those inequalities which would yield to what we listed here. So what we have is that the upper sum with p sub star of f and alpha minus the lower sum with p of f and alpha, well, that's going to be less than epsilon over 2 plus epsilon over 2, which equals to epsilon. So what that just showed is that f is going to be Riemann-Stieltjes integral with respect to alpha. Okay, that's great. We now want to show that we know that f is the addition of f sub 1 and f sub 2 is Riemann-Stieltjes integral. We'll show its integral is equal to the sum of f sub 1's integral plus the sum of, plus f sub 2's Riemann-Stieltjes integral. Okay. Now, note, since the upper sum with this refinement partition of f of 1 or 2, so I'm going to write down f sub j here, of alpha minus the lower sum with the same index, okay, either they're both 1 or they're both 2, alpha is less than epsilon of 2, we have that the upper sum is going to be less than epsilon over 2 plus L of the lower sum. So we have that the upper sum is less than or equal to, or less than, I should say, epsilon over 2, and then here we get something bigger, so if we take the sups over all these partitions, we get the integral of f sub j d alpha. Now, since we have that the Riemann-Stieltjes integral of f is going to be less than or equal to this upper sum, well, not this upper sum, but the one, any upper sum with the, not any, but the upper sum with the refinement partitions in f and alpha. Remember, this Riemann-Stieltjes integral is the minimum of all of these partitions. And then this is less than or equal to the upper sum of f sub 1 alpha plus the upper sum of the partition, the refinement partition, with f sub 2 of alpha. We have that this Riemann-Stieltjes integral of f is going to be less than, okay, This guy was epsilon over 2. Here there should have been a plus. So it's epsilon over 2 plus f sub 1 d alpha plus epsilon over 2 plus the integral of f sub 2 d alpha, which of course is equal to epsilon plus the integral of f sub 1 plus the integral of f sub 2, and you should have d alpha. And since epsilon greater than 0 is arbitrary, what that yields is that the integral of f d alpha is going to be less than or equal to the integral of f sub 1 d alpha plus the integral of f sub 2 d alpha. So we don't have the result we want. We don't have the integral of f is equal to the integral of f sub 1 plus the integral of f sub 2. We've got an inequality there, but we'll show the opposite inequality in just a second. Okay, similarly, since the upper sum of p star f sub j alpha minus the lower sum p star f sub j alpha is less than epsilon over 2, we have that the lower sum is going to be greater than the upper sum, so the upper one is small right here, minus epsilon over 2. So we have this lower sum is going to be greater than, well, it's going to be less, less than, I'm sorry, greater than. This here is going to be integral of f sub j d alpha. Remember, here, to get this integral of f sub j, we take the infimum of all of these. So we've got smaller, minus, that's smaller. Since this lower sum with j and alpha, no, that's 1, excuse me, not j, plus the lower sum with f sub 2 and alpha is less than or equal to the lower sum, this partition with f, their addition, and alpha, which we know to be less than, this is the soup, this integral is the soup of all of these, the integral of f d alpha, then something smaller than that is written right here. So the integral of f sub 1 d alpha minus epsilon over 2 plus the integral of f sub 2 d alpha plus epsilon over 2 will be less than f d alpha. So what we have is that this integral of f sub 1 plus f d alpha plus the integral of f sub 2 d alpha minus epsilon is less than the integral of f d alpha. Since alpha is arbitrary, since epsilon is arbitrary, then what that's going to force is that the integral of f sub 1 d alpha plus the integral of f sub 2 d alpha is going to be less than or equal to the integral of f d alpha, which is the sum. And so, so what we have is that the integral of f d alpha must be equal to the integral of f sub 1 d alpha plus the integral of f sub 2 d alpha. And just to make it clear, this says that f was f sub 1 plus f sub 2 d alpha is equal to the integral of f sub 1 d alpha plus the integral of f sub 2 d alpha. Okay, that's the main part of this theorem. What we want to do next is we want to show that C times f sub 1, I'm just going to say C times f, is an element of the Riemann integrable functions, Riemann-Stieltjes integrable functions, with respect to alpha, where f is Riemann-Stieltjes integrable. Not only that, and that if you integrate this C times f d alpha, what you get is C times the integral of f d alpha. Okay, so we're going to divide this into cases based on C. And so the first case is when C is greater than 0. Now here's what we're going to say. We're going to note that the supremum over the subintervals from x sub I minus 1 to x sub I for any partition of the f of x, that's going to be greater than or equal to f of x. You know, and that's for all x in this subinterval. So there we have that. And so, since C is positive, multiplying both sides of this inequality by C, we got C times the sup of the x sub I minus 1 up to the x sub I of the f of x is going to be greater than or equal to C times f of x. And that's for all x elements of one of these subintervals. Okay. And so what that yields is that C times the sup over one of these subintervals of the f sub x's is going to be greater than or equal to the sup of C times f of x over this subinterval. And so what that gives is that C times the upper sum of a partition with f alpha is going to be less than, or is going to be greater than or equal to the upper sum with any partition of CF with alpha. Okay, and then we can do the same type of logic working with the enthemas. So the enthema over the x sub I minus 1 of x sub I of f of x is going to be less than or equal to f of x. That's not the definition of the enthema. And that's for all x in the interval. Excuse me. And so, since C is positive, we have C times the enthema of the f of x
will be less than or equal to C times F of X.
So forgive me, I'll stop writing the subintervals here. And so what that says is that C times infimum of F will be less than or equal to infimum of C of F of X. Okay, that generates comments about the lower sums. So what we have here is that C times the lower sum with any partition of F alpha will be less than or equal to the lower sum with that same partition of CF times alpha. And thus that gives us this string of inequalities, okay? It's C times the lower sum of F will be less than or equal to the lower sum of the partition with C times F, which is less than or equal to the other sum with the partition of C times F, which is less than or equal to C times the other sum of F with alpha. Okay. So since F is Riemann-Stieltjes disintegrable, we know there exists a partition such that the upper sum, we'll call that partition P sub 1. Okay, so it's the upper sum of P sub 1 with F minus the lower sum of P sub 1 with F will be less than any positive number that we give. And the positive number I'm going to give is epsilon over C. Okay? So if we multiply everything by C, we have that the upper sum of C times the upper sum minus C times the lower sum with F will be less than epsilon. Okay. So what you see right here, if the distance between this guy and this guy is less than epsilon, the distance between this guy and this guy is less than epsilon. Oops, should be up here. And that's what it takes to have C times F be Riemann-Stieltjes disintegrable. Remember, we're working in the case that C is positive. Okay? Now, excuse me. Since C times this upper sum minus C times this lower sum, this is a piece of one, is less than epsilon, then what we have is the integral of C at E alpha will be less than or equal to C times U of P F alpha which will be less than epsilon plus C times this lower sum, P sub 1, this P sub 1, F alpha, I'm getting that from this line here, this inequality, which is less than epsilon plus C times something bigger than this is the supremum all over these partitions, which is just F d alpha. So, again, epsilon is arbitrary, so we have that the integral of C F d alpha, much like what we did before, is less than C times the integral of F d alpha. Similarly, excuse me, since C times the upper sum minus C times the lower sum is less than epsilon, then C times the lower sum, just like what we did before. That's a piece of one. F of alpha is going to be greater than the C times the upper sum, and then minus epsilon. Okay, so what this says is that C times the integral of F d alpha, remember the soup of those, so it got bigger, it's going to be less than C times the upper sum minus epsilon. Okay. I made a mistake here. Okay, really, it's the integral of CF here, and that's because the integral of CF that was bigger than this. Okay, and so the integral of the CF d alpha is going to be greater than, here we take the theme, so it's smaller, C times the integral of F d alpha minus epsilon. Again, because epsilon is arbitrary, we have that integral C F d alpha is going to be greater than or equal to C times F d alpha. And therefore, since we had inequalities going both ways, we have the integral of C F d alpha is equal to C times F d alpha. Second case, if C equals to 0, then CF is 0, and that's a Riemann-Stieltjes integral function. And its integral will be equal to 0, which equals to C times the integral of F d alpha, because the integral is a number and C is 0, so you get 0 both ways. Now, for case 3, if C is less than 0, we're going to consider two subcases. First subcase is if C equals to minus 1. Okay. And here's what we'll say. As facts, Turns out that the soup of minus f equals to minus the nth of f, and the nth of minus f is equal to minus the soup of f. Okay. Now, since f is a Riemann-Stieltjes disintegrable function, there exists this partition, we call it p sub 1 again, such that the upper sum of p sub 1 of f and alpha minus the lower sum p sub 1 f and alpha is less than epsilon. We'll look at what that upper and lower sum are. Okay, so, but this upper sum minus this lower sum, okay, this is equal to, I'll write it down, give my notation here, it's the sum of the big M sub i's with respect to f, remember that's the soups, minus the little m sub i's of f times the delta alpha sub I. But by the two facts that I had listed just a second ago, this is the sum of minus the little m sub I of minus f plus the big M sub I of minus f times the delta alpha sub i's. And that's equal to the sum, remember it's the sum as I run from 1 to n, of the big M sub i's of minus f minus the little m sub I of minus f times the delta alpha sub i's. And hopefully we can recognize that there's nothing more than the upper sum with the partition of minus f alpha minus the lower sum partition of minus f and alpha. And that's going to be less than epsilon because this is less than epsilon. So what that says is that minus f is Riemann-Stieltjes integral. Almost done. Now, we know the upper sum of p sub 1 with minus f, that's minus f, and alpha is equal to minus the lower sum of p with f, p sub 1, f, and alpha. So, the infimum of this will be equal to the infimum, and this is over all partitions here. So I shouldn't say p sub 1, I should have just said partitions here. Over all partitions of minus L of P F alpha but this guy is equal to the soup over all partitions it's minus the superboral partitions of L of P F alpha. And so if we look at these two things, this says that the infimum of overall partition of this is nothing more than the Riemann-Stieltjes integral minus F d alpha. And this minus sign just gets written down. And this guy here is the Riemann-Stieltjes integral of F d alpha. So we got the result for when C is equal to minus 1. So when C equal, this is subcase 2, and that has to do with C being different than minus 1. Remember, we're assuming C is negative. C is negative. Okay, then what we do is we do this very slick thing. C times F is really the same thing as minus C, which is a positive number, times minus F. And what we know is that since F is Riemann-Stieltjes integral, minus F is Riemann-Stieltjes integral, and minus C is going to be a positive number. So minus C times minus F is an element of Riemann-Stieltjes integral function with respect to A. So that says that C times F is Riemann-Stieltjes integral functions. And not only that, one little part of that. And we have that the integral of CF d alpha is equal to the integral of minus C times minus F d alpha. The C is positive, so pull it out. So it's minus C times the integral of minus F d alpha. But it's just minus 1. So it's minus C times minus 1 times the integral of F d alpha. And then this just makes C times the integral of F d alpha. So in all cases, we got what we want. That's in the proof. That concludes lecture 12. Thank you very much.